Good morning, friends. My name is Joshna. Today, my topic is Microservices Architecture. So, today I wanna tell you what are the microservices and how does it use, and what are those attributes that microservices providing to us. So, basically, microservices it is an approach for developing a software where an application is divided into small independent services that each perform a different task. So these services basically communicate with each other through some of the APIs. Already we discussed about these APIs. So through these APIs and making the system easier to develop, scale and maintain. So each service can be developed and deployed separately without affecting the others. And today we are going to see the attributes. What are the attributes that microservices be providing to us? So microservices, it is like from a technology perspective, what should we do in order to build the right system? Okay, we know that there is agile. Agile is also for the prospective, right? But agile, it is not a technology perspective. It is a process perspective of what we should do. But from technology perspective, we use microservices. How the system should be and how the practices should be done. So these all are that mentioned in the microservices only. So all of that are related work how we should do that comes under the microservices architecture comes for the project development. So the Martin Fowler and his team wrote a nice article with the 9 attributes of the microservices. They say if your project really want to follow the best practices to develop a project, so you need to follow these attributes. So everyone are not able to follow the all attributes. Basically, there are 9 attributes, right? But in every project, we cannot follow all the rules that are mentioned in these attributes, but we can follow some of the rules to make our project beautiful and good. So the first attribute that I am going to tell is component component componentization via libraries. So we know that in every project, basically the project is executed in the form of one process and occupied one port. We know that the port number which any process will defaultly take is port number 8080. Okay. Usually we execute these programs in the port number 8080, but due to the AWS demonstrated for the deployment, if 8080 was already running, what happens if there are different projects in our IDE? So then now port number 8080 is already running. So how we can restart it again? We can't restart it, and the another project can't use this port also if it is already in run state. So then what would we do to run the other projects hard to restart this project? Then now we have to find the port. We have to find what is the process that is currently running at the port number 8080. Okay, and to find that process, we have the what command. By writing this command, we can will get know what is the process that is running currently on the port number 8080, or whichever port number maybe that you have mentioned in your project. Okay, so this gives the process command. Now what we have to do means we need to kill this process in order to give this port number to other projects or restart it again. So now question is how to kill it, how to kill this, because when we run this command, when we run this command ps hyphen ef slash grep java, so it will give a pid number, it's pid value. So in order to kill this process, we need to use this pid, and need to write some command like kill 9 pid. Okay, now uh, this running port can now this process gets killed, and you can use that port again. Okay, so basically it is called as the monolith application, which occupies one process and take one port number, and the entire application runs as one. But there is so much while processing this code. If you're using this process, you'll write multiple java packages where like I will show in diagram. So just like, so you're using a monolith application, right? So here there are several projects. It's just like a process of PayPal process is there, and Stripe is there, and Calexa package is there, and if another provide it's just like a provider step, and we can use the one for the security related code and customer, and to communicate with the PayPal, we write some code also for the entire status management also we need that code. So in another, it's another service like every payment coming into the system have to validate it, that code, right? So that's why we are using another system also. So likewise there are several packages, each one is a different package. So this is all under the payment system. So how does it work means, so if you run this project it will run on 8080 etc. But look, uh, these all are the java classes. Look how much bulky it is, right? So in order to run it is very difficult also. So this payment system basically contains a lot of code in it, so it becomes so much chaos or tough to manage it, and tough to run it, tough to save it also. Okay, so what are the problems that we get to know if you're using the monolith application means, there are so many java classes are together in this project. So debugging is also very difficult, and easy to understanding also difficult, because it's a lot of code running here, right? So if there is any error occurs, how can we detect, how can we manage it, right? So we need to bug, if there are any bugs we need to debug. So that is this debugging also very difficult, very hard, become very hard if you're writing code like this. Okay, um, for example, if you have many providers like PayPal, Stripe, Calixa, okay, if there is any problem raised here, if there is any problem raised in the Caliph Stripe process also, so how to modify this? Okay, if there is a problem occurs, you need to modify it, you need to rectify this, and you need to redeploy this also. If you want to redeploy this also, you need to compile the code. So basically the command we use for the compilation is mvn.package. So if you do that, if you use that package, it compiles the entire project. So even that there is a problem in this Stripe only, right? You need to modify this bug only. But if you run this command, it will compile all these project. Now imagine how much burden is coming to our projects. So compilation is also becomes very tough if you are using this type of approach. So finally, if one line of code you want to change, so in the part of the system, the entire system and is getting impacted because of the in terms of building compilation, and as well as the running unit tests also. And some of the other problems are raised. It just like it provides heavy jar file, right? If you want to deploy in another file, if you want to give this dependency to another project, so there are so many people. If you are developing a project, so we need to give our jar files to another project, so they will download it and they can add them also, right? If you want to deploy this, or you want to put these jar files in the network or internet network for deployment, it will becomes hard because of the memory. It takes a lot of memory for this, and deployment also becomes hard. So if you want to deploy it, you need to kill the old process and restart the new process. You have to kill the entire existing system just because this stripe is just not working right. So why this why we need to um, why we need to deploy these PayPal and Calixa? Because there are no problems with it, and there are some of the security purposes. There are providers. There are many different providers. So why? And another problem that we get by using this monolithic application is starting is also so delayed. So if it is okay if this is a small project, so for example we are doing a small project like our project in the internship, right? So it is just a simple project. So if the issue is with this type of projects, it is okay. But what if you are dealing with the big projects, the enterprise level web applications like that? So these starting problem is so get delayed, and the applications cannot even open if you're facing these type of problems. So basically one of the way to decreasing this type of issues is following the componentization via libraries. We are now already talking about that. So let's say we have two project in IDE. Okay, let's imagine we have two projects in IDE like PayPal and Calixa. So from PayPal, when PayPal jar file is giving, this is I will show in diagram. Okay, let's so we have one PayPal project and we have one Calixa project in our IDE. So now we are taking the paypal.jar file from this by using the mvn.install command. So from that Calixa also we are taking this calixa.jar file. So now we are taking and we are creating one main app, main class also. So we are giving the name called main app. Now the jar files coming from that PayPal and Calixa, we are assigning to them in the map. Just like as these are the jar files, we can add dependencies to the main app class, right? Basically we are using that, right? If you want any jar files, we can go to the Google and download it, and we can use that in jar files in our pro in our projects also. So this is a normal process. So like that we are adding these type of PayPal and these providers in our projects, and add those dependencies in our project, and we run these single process, and it is also run in a single port. So now what is the difference? Okay, basically it is also calling just like a monolith application, right? It is also looking like that. So what is the difference between this? It becomes a it decreases the burden, just like monolith application writing the entire code in a single page single project. So when compared to that, it decreases our burden little bit. But what the microservices architecture is providing the solution for this means, so every project, so I'll show in diagram. So this project is needs to be divided into services, right? So now each system is one of the service, so make it a service. Okay, so every project needs to be run in its own process, and it's run on a own port. So we need to give different ports to the different services. So now become PayPal became a service, and Calixa became a service, and validation became a service. So these are the services that we are using in our project also: PayPal validation service, and PayPal provider service. So these are also our project services. Now each and every process runs on a different port. So this is how what the componentization via services is telling to us. If you are follow this approach, then this burden will decreases, and each service is running on different port. So the we are port, and we are dividing our entire code into different parts. So this decreases the burdens, and if you want detect any errors and we want to rectify those errors, if you want to debug those errors, it this becomes easy, and it will become fun. Otherwise it is very difficult to run these programs. So now I am going to tell the second attribute is organized around business capabilities. So let's say for example, let's say our almara or something. So if our dresses are not in a structured manner, how we can access them, right? So it is mandatory to organize them in a proper way, right? So as same as using the same logics, these microservices architecture is providing us a attribute called organized around business capabilities. So each service here should be organized around the business capabilities. So look at the business functional first we have to look at the business functional requirements and related functionalities you put together inside one service. In the overview of the project we also see this, how here it is our backend, it is e-commerce client, it is our backend, and it is PayPal itself, right? So here we are dividing our code into different services based on the microservices. So now how we are dividing this code based on what functionalities we are dividing these microservices means, based on the business functionalities, right? So the validation codes is that the validations that we are using in our code, we make it. Okay, so here we in our project, so we are dividing our project into, this is the payment validation, and this is the process, this is the payment process, and itself it is a PayPal provider. Okay, now here what we write means, so any validations logic we will write in this service, validation service. So if you have a more validations, if but it is okay if it's simple validations, it is okay. What if the validation service becomes bulk? So it is also difficult, it is also difficult to manage situations, right? So at that moment microservices architecture also provides a capability to divide those validation service to other services. It is okay to devise these validation services to another services. So in processing, what we write in processing, payment processing service means the core logic for the processing the payment, and also the status like what is the payment status, and is that approved or not, or this is the payment is completed or not. This type of logic comes under this payment processing. And what it comes the PayPal provider service means the integration code to talk with the actual PayPal PSP. So we need to interact with the PayPal, right? In order to make a payment, we need to interact with the PayPal. How we can interact means through some APIs. But in order to connect in a secure manner, we need to give we are using the authorization. We know that. So here in this service, we need to give implementation for that oath of the PayPal. So this type of works are done here. So this is all about the organizing of data by which is microservices architecture is telling to us. And the third attribute, it is nothing but decentralized government. Decentralized governance. Okay, basically first understand what is a centralized governance. That's how we can understand what is the decentralized governance, right? So centralized governance, there is some central governance authority who will make decisions, standards, which everyone follows during the development. So basically just like our government, yes, in this industry also we have one government, it has rules and standards which we have to follow. Okay. But why we are saying that decentralized governance means, so if you're following these structures, sometimes you behind, you sometimes you no need to upgrade, you don't have to upgrade. Okay. But what happens if you are not upgrade? You will become um, something like not upgrading state, right? So whenever you feel like a new software is good to your project, you can add and use, because the microservices giving the provision to explore on that, make a decision on team, and implement it also. So because this upgrading is important in this generation. Okay. Because this industry is developing day by day, that's how you always be dynamic and updated to the latest trends in the IT industry. Okay. The the attribute, the next attribute that we are going to discuss is decentralized data management. So each microservices should have its own database. This is the main important thing, that is the decentralized data management set. So basically, if you are developing a project, we basically use one single database for the entire project, right? But this microservices architecture, this is not suggesting for us like that. So if one service wants to communicate with another service database, it is not impossible. So now we are creating each database for the each service. So we have the, I said that we have the payment validation service, and we have the processing service, and we have the PayPal payment service. So we need to create each separate database for the entire service. And if the one service, basically if the one service, it's a, like the payment validation service need to talk with the processing service, but it is not allowed. Okay. It is if something data is needed by the payment validation from the processing, it needs to call to the processing, not to the database. Processing through the API calls. If it so now the processing will connect to the database, and it takes the data and it will return back to the payment validation. Okay. This is how process works. Then that another service goes to its DB, performance action, and then it results back to the service. So in our project, I said we have the validation process and PayPal provider also. And the fifth thing we are going to discuss is infrastructure automation. Infrastructure, sorry, infrastructure automation here. So what is the infrastructure automation means about? So if you are developing a single service, let's say how many the steps we need to follow. Like we need to add our project in IDE, right? So we need to take branches like master, integration, feature, branch. We need to divide that, and we need to put that in bucket. And we need to add to it a clone local mission and import into the IDE. And we need to do some code changes and cleaning the package. And there are so many steps, right? But it is okay for single microservices. But what if it in our project it has multiple microservices? We need to do these steps only. We need to take these steps again and again. How we can write? So it gives a burden for the developer, right? So that's how how this infrastructure automation works, right? It provides automation by using CI/CD in the DevOps. So these all steps are inbuilt, it's providing to us. We can just add them and use them. So what is the tool for using these is Jenkins, one of the tool to use this. And the sixth attribute we are going to discuss is products, not projects. because it is not always suggestible to change companies, because if you are working in a company, we are working on one single project. If you change, so we are not working on the project. It tells us to work in a same project for several years just like that. So the microservices treated as a long-time products with ongoing ownership and responsibility. So this approach encourages teams to prioritize quality, readability, and maintainability for storing a culture of the continuous improvement and customer centricity. And the seventh one we are going to discuss is design for the failures. Basically, we all are ready for the successes, but we are not ready for the failures, right? But in projects, we need to ready for our failures also. So if you are trying to make a payment, there is a possibilities that it may success occur or it may failure also occur. It's somehow it will take long time. Timeout may also happen, right? So if what should we do if success happens? What to consider as a success as API response? We need to understand what to consider, and what do we do when success API responses comes? What to consider and how to respond. You have to understand this also. And what if failure happens? So if a failure happens, we need to understand what to consider when the failure API response happens, and what do we do when failure API response comes? Just like that. What to consider and how to respond to that. Because it may possible, anything may possible, right? Not always success comes, and failure also comes. We need to ready for that also. And sometimes it's timeout happens. When timeout happens, don't feel like it is an error, something like that, it is the execution failure. Don't take like that. Timeouts somehow it is a success also. It's just nothing in the state of I don't know what happened, and we need to think wisely and handle those. So we need to think and handle those timeout problems. Yes, that is, don't be panic to do for those also. And if I try and double processing happens, is that okay? If okay, then so these are the situations may come. So never take this as a failure first thing. So is there any possibility you can call that one service, and it will tell you what happened earlier, and accordingly make a decision to handle. So the final step I am going to tell is the evolutionary design. We know that evolution is so important, right? Because in the IT industry it is much more than important to be good at the latest industry and to upgrade our skills to the latest industry side. So the microservices prioritize evolutionary designs, because the fixed designs it is not recommended by the architectural design. We need to improve our projects, and we need to add some of the softwares. So if our project is good, if our payment validation is good in Java, we can use Java. If the processing is good at the something, it's like a Golang something, etc., we can go through that. So if a project is we need to understand in what language our project is good, in what language it runs so fast. We need to understand, we have to upgrade that, we can change the softwares too. So this is how this needs to be done. And it is also we need to incremental improvement over the unfront palings and monolithic architecture. So services evolve iteratively based on the feedback, changing requirements, and emerging businesses needs, and enabling organizations to adapt quickly to market dynamics. So this is the final step. Evolutionary design means we need to upgrade. So the code needs to be improved. So these are the steps. So let's look at the so the steps are componentization via libraries, and these organized around business capabilities, decentralized governance, decentralized data management, infrastructure automation, products not projects, design for failure, when success failure happens, time and evolutionary designs. So these are the steps or attributes that microservices is providing to us. We need to follow these steps in order to develop a secure and good upgrading the project. Okay, just follow these steps and make a good project. And thank you for this opportunity.